Okay, so here we are talking about the freshman 15 and flights. So our problem has to do with that freshman 15 we talked about in problems before. It's that data set. So weight measurements of students were made in September of freshman year and then later in April of freshman year, and the weight difference was calculated. And I just realized that this weight difference doesn't make sense. If it's April minus September, then if you've gained weight, that will actually be a negative number. So let's just cross that one on out. I actually had it calculated when I went through all of this to be September minus April, and I just forgot to update it in my instructions. So it should really be September minus April. If you gained weight, that will be a positive number. So the weight distances I found out were approximately normally distributed. So of course that's important, I'm underlining that. And had a mean of 1.4 kilograms. Notice again, it's in kilograms and not pounds. So I wrote down mu is 1.4 kilograms. And then they have a standard deviation of 3.5 kilograms. Again, sigma equals 3.5 kilograms. So our first question is to find the probability that one randomly selected student has a weight gain of 15 pounds, which again, it gives us in kilograms as well. So we're going to use the 6.8 kilograms or more. And of course, or more is important. I hope right now that you are picturing that normal curve, and the or more is telling you that you're going to be shading to the right. So, as all of our problems have been lately, we're going to start out by drawing that normal curve. So here we go. Draw it in, and of course mine aren't perfect. I feel like they're actually getting worse the more I draw them. In the middle, I'm going to put the mean. So I have 1.4, and then one standard deviation up would be my 1.4 plus 3.5. Because I don't want to get it wrong in the video here, I'm going to go ahead and calculate it just to be sure. 1.4 plus 3.5. I'm going to end up doing that 2 more times, so I'm just going to go ahead and get those numbers. Okay, so 4.9, 8.4. 8.4 is 2 standard deviations above the mean, and 3 standard deviations above the mean is 11.9. I also have to go in the other direction, so 1.4 minus 3.5, and I'm doing this 3 times. So negative 2.1, negative 5.6, negative 9.1. And of course, hopefully you're thinking in your head, you have to remember to label your normal curve. So N stands for normal, and then my mean, 1.4, and my standard deviation, 3.5. Okay, so I have my normal curve. Now I need to shade in what I'm actually interested in. So I'm going to try to change color here. Okay, so I want 6.8 kilograms or more. So 6.8 is going to be between 4.9 and 8.4, about in the middle or so. It doesn't have to be exact. And then of course it's or more, so I'm shading above that point. And of course I'm thinking, oh, this is a right area. That makes things just slightly more complicated for me. Okay, so I am now going to move to the next step. After I draw my picture to represent what I want, I need to convert this to a z-score in order to use my table A. So I write out my z-score formula. Z is equal to the value x minus the mean, which in this case is mu, divided by the standard deviation sigma. And I fill in. My value I'm interested in is here at 6.8. And I am subtracting the mean, which is 1.4, and then dividing by the standard deviation of 3.5. Okay, so I'm going to type that in all as one string in my calculator. So I have parentheses 6.8 minus 1.4, end parentheses, and then divided by 3.5. All right, I get several decimal places. I don't need that many. This is a z-score. Table A only has 2 decimal places, so I'm going to round. Looks like it's going to be 1.54. 1.54. Just to help those of you that are really interested in formulas out there, whenever I go to table A, I don't have to write this down, but a lot of you like it, so I'm going to. I'm really looking for the probability that my z-score is greater than my 1.54, right? I want or more. And so whenever I'm looking for that right area, I have to subtract, take 1 minus the left area, which is the probability that z is less than 1.54. Okay, Okay, so to get right area, I have to take 1 minus the left area. And this is where I'm going to look at my table A. So I don't want the negative z-scores because obviously I have a z-score of positive 1.54. I'm going to flip over to the positive side and I'm scanning down here. I see 1.5 and I want to line it up with 0.4. So I'm following the 1.5 to 0.4. I see 0.9382. So 0.9382 is my left area. So 1 minus 0.9382. And let's calculate that real quick. 1 minus 0.9382. Oh, typed in the wrong number. Whoops. Okay. 2. There we go. 0.0618. 0.0618. All right. So that is my area. Let's see. Let's actually write what that represents in terms of probability notation and the value. So instead of using z, I'm going to use x. I'm going to say this is the probability that my value x is greater than 6.8. That was the kilograms I was interested in. That is a probability of 0.0618, and it matches my picture, right? This isn't very much. It's definitely less than half, and my probability is only, is less than half, so that matches. Okay, so I would also want to write a sentence for this, but I'm not going to make you watch me write a sentence, so I'll include that in the filled in notes as well. But just know that you will be required to answer in full sentences on your take-home test. Let's see, the only other thing about this problem that I want to show you is the calculator command if you would like to use it. So if I want to use my calculator command, this is a normal CDF problem, normal CDF. So it's going to prompt me to plug in a couple of things. So I'm going to show you my calculator. To get to that, I want this distribution function. So since in blue, I know I have to hit second distribution to get there. And then of course I choose the normal CDF option, which is where I type in my lower, upper, mu, and sigma. So my lower, since it's a right area, is the lower bound of 6.8. My upper is some really big number. That's already plugged in for me. That's fine. So let's fill that in on our paper. We used 6.8 as the lower and some really big number as the upper bound. And then mu and sigma are my mean and standard deviation. So my mean is 1.4. My standard deviation is 3.5. Okay, I paste it in, I hit enter one more time, and I get 0.0614. Oh, I have to fill in 1.4 for my mean, 3.5 for my standard deviation. I end up getting 0.0614, which is very close to the answer I got just using table A. Remember, the calculator is technically more accurate, but table A is accurate enough. So there we go. That is the answer to number 1.